Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Optimized WOA-Bi-LSTM based Text-Independent Speaker Recognition Approach. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Hello friends, welcome to TechPacks Research and Innovation Services. Today I am here to present you one of the recent research that we have conducted by using the artificial intelligence in the real-time areas like speaker recognition, which is very much popular these days. So before moving to the video what we have developed, let's see what we will cover into the video. In the video, we will initially talk about in which application area this speaker recognition can be useful. Then we will talk about what exactly the code is, how we have developed it, which software we have used, and how to execute the code. Then we will discuss about the what are the current state of art areas or researchers have done into this, and what are the problems identified in them, and how our proposed system is providing the better solution in comparison to them. Finally, the experimental outcomes and the findings will be discussed. So let's talk about the application area of the speaker recognition. These days, speaker recognition is very much popular, and it has the reliable solutions like in the call center operations, in the robotics, even in the criminal investigation, where the speaker speech from the speech they can recognize that whether what is happening and what kind of actions further they are going to take. Even for the smart speaker like Alexa, Google related devices, those are also using the speech recognition. So here speech recognition is not the new thing, but speaker recognition is more related to the security. Like for example, if you are just need to recognize that what I am saying, then it is easy to do because speech recognition is happening with many of the advanced models. But speaker recognition is specifically identifying who is speaking. So it is now currently in many of the smart devices like in car systems, in the healthcare systems, for the education purposes, for interacting voice responses and translation related works. So in these all application areas, whatever the system we have designed, that can be realistically implemented and be useful. The challenge is to achieve the higher accuracy rate. So let's talk about the code now. We will provide you the folder in which there is a code folder which is having all the files. In order to run the code, you must have the MATLAB software with you. The MATLAB version that I am using is R2019A. So you can use 2018, 19 or the above, but make sure that should be a full version of the MATLAB, not the trial one. So to run the code, you just need to go to the folder. So this is the database folder having the speech of the different speakers. So we have considered 5 speakers having a number of 101 count of their speeches. So this folder is there. So you just need to go to the main folder where the code is there and the database is there, and just copy the path of the folder. Then go to the MATLAB and just paste it here and press enter. When you will press enter, you can see all code and the database can be seen here in the current folder. The code that you need to run is the main code. Rest all 3 files are the functions, those are called in the main file. So in order to run this code, you just need to click on the run button and it will start executing. So now in the meantime, as it is running, let's talk about that what are the current system, what exactly they are doing. So here you can see every sample given in the dataset has been processed and the database is being created for the further procedure. So the base paper that we have selected for this system is like this. In this, text independent speaker recognition was proposed with them, in which they have implemented the LSTM RNN model. For feature extraction, you have used the MFCC, that is mel frequency septal coefficients. So the problem that we have identified into this is like they are using the MFCC features. That is best because in the audio, this model MFCC model gives you most of the features those are required for the audio recognition. But whether every MFCC pattern is mandatory, because it provides us a lot of feature set which can create the complexity for the system. Secondly, might be any of the feature set must not have the pattern, so it can give you the unnecessary information to the network for getting trained. So this is one of the challenge that we have identified. Secondly, they were using the LSTM, RNN's LSTM model, which is the long short term memory recurrent neural network. So what we have identified from the literature survey, we have identified that RNN is an advanced deep learning model, but LSTM is one of their variant. LSTM's advancement is also possible. So there is one model named Bi-LSTM, which is bi-directional long short-term memory recurrent neural network, and it is proven to be the better in terms of the LSTM. So if you want to read about it, you just need to write Bi-LSTM and LSTM. So there can be the certain articles from where you can get the comparison. So let's see, this is an example that people generally ask, that is bidirectional always better than the LSTM? The present work provides a statistical conclusion that Bi-LSTM outperform the LSTM according to the test performed. So in most of the cases, the Bi-LSTM outperformed the LSTM. So inspired from the literature that we have conducted in the same domain, we got that Bi-LSTM is better than the LSTM because it has reverse direction of the information flow also, where LSTM is always into the forward direction. So obviously the linkage among the data can create more better results. So now let's see what is happening in our system. The training is under process right now. What we have done into the proposed system, in the proposed system we have used the database which this paper was using. Let's see which data set they have used. So you can easily get it from the kaggle.com. So let's search data set. So the dataset description is here. So they were using Chinese this corpus dataset. So we were using the same dataset. They have the 5 female speaker with the 100 outruns. So I have already shown you that the sample dataset that we are using in our model. So each and every sample from the dataset folder for the every speaker is being read here. Then we are extracting the audio from it. Then we are calculating the MFCC feature from it. After calculating the feature, we are saving their mean features. Then when the set of all features has been extracted, we are also plotting them. So you just saw this graph. This is the actual sample of the audio. These are the plot graphs of the MFCC features, and then what we had made in the average mean of the all the features in this. Then we are applied Wolf optimization algorithm in order to select the best features, where we are evaluating the parameter in terms of the standard deviation, that one by standard deviation, mean standard deviation, which set will have the highest information in that, those are get selected in the leader position. So the best feature selected after running multiple times, we got this set with the best one. So I'm just commenting it. When the code is running, every time it can give you the different feature set. So the best feature set is to be selected and further training is to be conducted. So we just wrote this in order to, because we have run a number of times and got the results from the leader position that this feature set is the best feature set. So we have used this, then it shows the convergence curve, and further we have used the RNN's Bi-LSTM network. So here you can see Bi-LSTM network is being created and then training is being conducted. Finally the parameters like accuracy, sensitivity, specificity, precision, recall and so has been evaluated. So as training is under process for the number of iterations that we have mentioned, and a comparison is being done with the existing methods, those were provided in this base paper. So they have given the results for MFCC, log spectrum and their own method. So we have compared our proposed with all the four methods given in the base paper. So let the training get finished so that we can get the results. So you can see even lesser amount of iteration is being conducted, and still current accuracy that is achieved by the our model is around 100. So it is already 100 during the training. So let's see how it perform for the testing outcomes. So it will take some time to get trained because the iterations that we have mentioned here are around 150. So the maximum epochs given by us are like 150. So currently we are at 137. So let's wait for 10 more epochs to get finished, and then we will see that what is the performance that we get. Here the model that we are using for the training is Adam, and rest all the parameters are defined into it, that how many epochs, what will be the gradient, what will be the maximum batch size for the training will be there. So this is how we have developed the whole model, and by using the WOA, so you can see the accuracy that we have achieved for the proposed model is 98%, sensitivity 97, specificity 99, and so on. Let's see how it performed with the previous models. So the results that we got are these are the proposed methods parameters only. So in the comparison, we got the results like this, where you can see in terms of the accuracy, the proposed methods accuracy is higher in comparison to the traditional method, which is around 98.7. We are achieving at 98.9 or 8. So as many times we will run the code, every time the results will different. So we need to save the best model, which is having the better results in comparison to the other model in recognizing the speakers. Further modifications are still possible. For those information, you can contact us directly. These trained models can be used in the real world scenarios in using the Android based or server based application, where speaker recognition can be the base for any of the service provided by the users. So I hope you people like this video. Thank you. Thanks for watching this video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPax, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPax. We look forward to collaborating with you on your research journey.